Welcome to another Juniper On Demand webinar. Today, our topic focuses on zero-touch deployment, automating network device configuration. My name is Robert Tang, Senior Product Marketing Manager focusing on network automation. I'm your host today. We have two exciting panelists for our webinar, Martin Smihula and David Church. Martin?
Hello, I'm Martin Smihula. I'm a Senior Consulting Engineer with Juniper Networks. I work in the Center of Excellence on the automation team.
Hi, and I'm David Church, the Director of Engineering and Product Development at EATEL.
For today's webinar, we'll start with an overview of ever-changing market environment. This is followed by an in-depth description of automation and programmability of Juniper solution. Our partner EATEL will then present their device automation experience. We'll wrap up this webinar with a brief summary. We divide the market changes into three pillars: service evolution, enterprise requirements, and consumer behaviors. From a service evolution standpoint, we see a trend of cloudification in the last couple of years, where a number of applications have shifted to the cloud. We'll continue to see the acceleration of this trend. Combined with this is software innovation, the ability to deliver automation and on-demand capability that rapidly scale, whether scale out or up as required by customers. The emergence of telco cloud, IoT, 5G technology are also some of the trends that are driving these changes. And combined with evolving security threat and dynamic security requirements, all these factors contribute to the service evolution. Next, let's take a look at enterprise. Enterprise requirements have changed over the years. They're moving into a cloud model consisting of private, public, and hybrid cloud. This multi-cloud approach created diverse use cases, different economic models, and regulatory requirements. On top of this, enterprise are demanding pay-as-you-go model where they will only willing to pay what they consume. Combined with policy-driven approach and rapid service delivery via self-care portal, where enterprise consumer can configure and monitor their network services. The last pillar is the consumer behavior. Consumers are expecting personalized and unified experience across devices, location, branch, and home. They're also expecting on-demand service delivery models. These are overall expectations of the marketplace today. Service providers have embraced these market changes. While they have made headway in transforming their business, there are still several challenges ahead. From a business standpoint, enterprise and consumer today expect service on demand, so agility and speed to market have become crucial. Business models also have evolved from a subscription-based model to a pay-as-you-go consumption model. Combined with this is security compliance, including deterrence against threats, security breach, and privacy protection. From a technology standpoint, the combination of physical and virtual infrastructure have increased overall network complexity. This, coupled with technical debt from legacy or proprietary closed systems, require extensive point-to-point integration. And often in case, this integration are manual intensive, error-prone, and time-consuming. Last but not least is the process challenge. Many service providers have relied on outsourced IT, resulting in a slow turnaround, further impeding time to market. Traditional waterfall development approach still prevail, resulting in a lengthy development process with large release blocks. And an inherent risk that when service finally becomes available, the market condition might have changed. Service providers are also in the process of embracing DevOps, the elimination of internal silos, alignment of resources, and collaboration between development IT. Network automation addressed many of the market dynamic and challenges we discussed earlier. A programmable network automation solution based on open source framework, open data models, coupled with standard network interfaces can effectively streamline networking tasks, including network device provisioning, management, and operations. Network automation simplify operation, eliminate human errors, free up valuable resources while improving overall operational expenditures. Juniper Network Automation Solutions made it possible through programmability advancement and open framework provided by Junos OS. Junos supported on-box automation programmability and open API since its inception 20 years ago, where it leveraged open standard transport language and data model, which later became effectively the industry standard. Martin, Junos OS has supported on-box automation and open API since its inception over 20 years ago. Can you provide an overview of automation capabilities, particularly revolving around device configuration and management?
Sure, Robert. Let's start with the Junos automation stack just to set a baseline. So underneath the hood in Junos, and if we start at the bottom of the diagram, everything is XML. And so this Junos was built with automation in mind. And as we move up the stack, so we see our chassis and our data plane, our packet forwarding engine there at the very bottom. That's how we interact with the hardware and the router. Junos sits on top of that and provides that interaction. However, the main access method is through what you'll see in the middle, which is the XML RPC, or remote procedure call. So when we're on box, whether we're using the command line interface, or we use something like the web interface, JWeb, or we have an on-box script, we're going through making a series of calls. So if I do show interfaces as a CLI command, what I'm actually doing is calling get interface information RPC. What that will do is that's an XML call to the OS to extract that information about interfaces and bring it back, and it displays that in an XML node set. The CLI obviously strips off that XML and shows you a nice tabular viewpoint. However, programmatically, what this allows us to do is instead of screen scraping and having to do regular expressions and things like this in order to extract that data from the CLI, what this is allowing me to do is to be able to walk through that node set in a very structured format and easily extract that information to process. And like I said, we can do that in multiple ways. Other things you'll see here is SNMP. We can get those type of statistics out. And then there's other ways, what we call JET, or Junos Enhanced Extension Toolkit, which allows us to actually go to the processes or daemons themselves to be able to get that type of information. So Junos, you'll see, provides many ways while you're on the box to be able to do that. It also provides that information on an off-box format, and we can get there through netconf, which is a standard protocol that essentially provides for the encrypted communication, so usually over SSH, and allows that XML transport to go back and forth. However, we do have things like REST, though, as a standard interface if you were to use HTTP instead. So there are multiple methods there. And then you as the administrator, all those things kind of happen underneath the hood. How do you actually interact with that, and how do we plug into tools? So we'll talk more about some of the languages, but there's things like PHP, Python, Ruby, and there's different frameworks that have been created to make it easier to use those. But we also plug into popular tools such as SaltStack, Ansible, and so on. And then finally, we also have the capabilities when you're looking at abstraction and you're across potentially multiple vendors to use OpenConfig and Yang to do data modeling. So all these taken together provide a simplistic way to get to it and a flexibility depending on the tool you're trying to use. So Junos provides for operating scripts whether that's on the box or off the box. And when we look at on-box scripts, what that allows us to do is to interrogate the hardware or configuration, and all that operates locally on the device. We break those into a couple different buckets. The first is what we call a commit script. So if you're familiar with Junos, we intercept a commit when you go to make a configuration change, and this allows you to do multiple things. For example, something that would be syntactically correct and from a Juniper perspective not incorrect. However, in your operational environment, especially in a production, it may not be something you want your operators to do, as in the delete protocols command, which would delete all your routing protocol configurations, right? That could be very bad in an operational environment. So what you can do is you can, in a commit script, you can keep certain commands, even though they're valid, from being executed. Other things you can do is you can ensure that certain configuration, when you go to apply, say, VPN, that VPN not only creates on the primary hub, but you also enforce that it creates on the backup hub. So another bucket that we have is what we call op scripts. And so instead of looking at the configuration changes, op, as its name, looks at operational commands. And this could be something as simple as being able to aggregate information into a summary screen. So you may run 8, 10 different show commands and then parse out the specifics that you want to show in a summary view to make it easier so the operator doesn't have to go through and do all those different commands. You can also do something, though, that helps with troubleshooting. So, for example, if you get the NOC gets a notification that certain users are not able to access the internet, and you're an enterprise with a handful of peering points to your ISPs, that frontline technician can run an op script that could collect the information about what are those routers that are connecting to the ISP peering points up? Are their interfaces up? Are they accepting routes? Are their peers up and running correctly? Those type of things. That information can then be propagated to that L3 engineer that's going to troubleshoot the problem. And at a minimum, they'll know what it's not. And ideally, that will help point them in the right place. All of this can reduce the time troubleshooting so that L3 engineer doesn't have to go through and do all that work to figure out where the problem is actually happening. And then the final bucket we have is what we call event scripts. And that's essentially when a certain event happens, you want to take specified action. So for example, you have your primary WAN link, and even though from a routing perspective, a routing protocol perspective, that link is valid and up and running, you're exchanging hellos and so on, you can run something like real-time performance monitoring that's measuring latency and other factors across that link. And so, yes, your hellos are getting across, however, your latency hits a certain threshold over your specified time that says that, yeah, this is at this point we want to actually switch to a backup path in order to have the proper integrity we want for that link. So that can be signaled through an operational script to listen when that event occurs. Then it can actually make a configuration change for your routing protocol wouldn't necessarily be able to find that.
Martin, thank you for the overview. So just a quick question. How is Slack compared to other scripts, let's say Python?
Sure. So Slack was created by Juniper. It is open source, but it was created as essentially a preprocessor for XSLT, right? And this is that low-level manipulation of the XML that we were talking about previously. So it's great at its job, which is to be able to iterate through these returned XML to extract properties and then be able to do basic programmatic functions on those. However, it doesn't give you near the spectrum of something like Python will to be able to A, make it simple to be able to see that, and B, be able to pull in other modules and other things that are a full-featured batteries included type scenario that Python provides you. So as we just talked about with Python as a popular programming language, especially in the networking space, while we have many libraries that can use other programming languages that are popular, such as Ruby and Java, we focused on Python. We created this micro framework we call PyEZ. And the goal behind this was to make it easier to process the data that's coming, to extract that data that's coming out of that XML that we talked about underneath the hood in Junos. We do that a couple different ways. And so if we think about from an operational state, what Slacks was good at was being able to gather this XML and then iterate through it to be able to grab properties such as for an interface, statistics, bytes in and out, errors, and so on. What PyEZ does is it makes it much simpler to be able to iterate through those and uses a concept called tables and views. So instead of having to know how to go through and manipulate the XML, that's extrapolated for you, and now you just set up a simple YAML file to be able to say, this is the information I want, and I give a simple path like I would for a directory to be able to say this is where it is, and I want to assign that information to a variable, and now I can use all the power that Python provides me to easily manipulate that data. We can also do something similar when it comes to configuration. Again, you go through, it bundles in the transport in order to be able to communicate with that endpoint when you run this remotely. So netconf is the primary transport that we talked about, so you don't have to worry about making that connection, doing the authentication. It does all these things for you. PyEZ also bundles in utilities that are common. So for example, software upgrades. It makes it very simple to do that without having to go through and knowing where all the XML structure that you have to handle. So you put all that together. This has been a very popular open sourced tool that's out on GitHub, and anybody can download and use. So as an example of Junos automation in action, we've created a tool we call JSnap, or Junos Snapshot Administrator. And then that originally was written in Slacks, and then we've come out with an updated version that's written in Python, so we call it JSnappy. Essentially what this tool was designed to do was to take a snapshot of an operational environment before, say, an upgrade. So if you have 20 routers that you're going to upgrade, what does the route table look like as far as the number of routes in the routes themselves? What are the BGP peers or other routing peers that are going on, that neighbor status? Then once we have that snapshot, we go ahead and do the software upgrade. Then we go back and we take a second snapshot after the upgrade, and then we do a diff and compare the two. And so this allows us to compare this operational data that I wouldn't normally have a way to save, or I would have to manually go through and do a bunch of show commands and everything in order to get it. This allows you to extract that and then quickly compare the two to figure out of the 20 routers I was upgrading, there's only 2 that had problems, and specifically, one, even though its peers are up, it only has a quarter of the routes it should, and the second one has many peers that are down, so I can go through and start spending my time digging into those things instead of having to manually go through and look through each device to figure out what happened or what didn't happen. There are many other uses for JSnap. For example, when you think about something like a golden configuration, you have an environment, and especially if you're talking large retail or other scenarios where things are kind of cookie cutter and they just have small differences, this allows you to go through and look for configuration drift. Was something changed out of band that you weren't notified about? Or just generally, let's go ahead and take a snapshot of the environment and make sure the configurations that are out there comply with what we've deemed as a standard configuration. So this is just one example of what can be done with Junos automation.
Martin, thank you for the insightful overview of Juniper device automation capability. Now David will provide an overview of EATEL device automation experience. So David, let me start by asking this. Can you identify some problem that you encounter in your network due to this initial lack of automation?
Sure, Robert. So initially our problem was being able to scale our workforce to be able to meet the demand of the growing business. We were wanting to launch new products and services based on a managed network platform, and we realized that it was going to be difficult for us to scale the technical expertise to continue to offer personalized, hands-on level of support as we grew the business. So without automation in place, we believed that we were going to be adding multiple people per year to the tune of 1 FTE per 20 customers. And really, automation was going to save us from having to do that. As we started to look through how we were going to accomplish what we were trying to do, we tried to identify what the challenges were going to be in deploying managed services. And the key areas were going to be high operational costs, slow time to market, scalability, and the inability to rapidly respond to the market demand. We understood that manual operations and the inconsistencies in device configuration was going to overcomplicate the different deployments. And if we could somehow figure out a way to make our customers as unique as possible, while also implementing a kind of a base config or template, we could eliminate at least probably 80% of the stand-up process. So we spent probably 2 or 3 months in R&D identifying what the golden config would look like on the SRX platform, the EX platform, and developed all of our automation around the deployment of those initial configs, as well as building the support tools for any kind of one-off config change that needed to happen. For example, VLAN changes or routing protocols and things like that. What that allowed us to do was kind of scale as our sales team was winning opportunities. We suddenly were able to go from 0 to 100 customers in less than 12 months. And for us, being a smaller operator, that was a big deal. It was a lot of new revenue that came in unexpectedly. We also wanted to be able to respond to the market demand that we saw. Where we sit geographically, we're kind of in between 2 metropolitan cities, the New Orleans and Baton Rouge markets, and we have a lot of business customers that, quite frankly, they want to focus on their business and not have to worry about IT and networking, and we need to be able to quickly respond to those demands. So with the automation and tool set that we deployed, we were able to respond to RFPs or sales opportunities in a matter of days and deliver those services and goods within 24 hours in some cases. So when we were going through the process of figuring out how we were going to go about solving the automation problem and the device provisioning, we knew that we wanted to leverage standard-based network interfacers, or we wanted to be able to use standard protocols. We found ourselves in situations in years past where we kind of got locked into technologies based on some of the things that we were doing. So we knew that moving forward, we wanted to use something that was common. We already had a team of developers who had been developing in languages like Python, PHP, and some other web languages. So they had a level of comfort with continuing to use PHP and using the netconf language or interface to talk to the different routers and switches and firewalls. So when we set out to build the automation, we knew that we could build solutions based on PHP today. We could also tie it into the other ecosystems like our IPAM or our monitoring, things like that. We didn't have to have any kind of specialized GUI, although there's some really good ones out there. We didn't have to have specialized technical resources that knew the CLI, and those resources that did currently know the CLI interface, they could be focused on doing other things within our business. One of the great things about Junos is that it provided us an interface to interact with, and I wasn't forced to use a specific language to get the job done. So I could have used Python. I could have used I used PHP. I could have used anything as long as I was able to talk over netconf.
Thanks for that. So in addition to PHP, what other tools have you considered for this automation project?
So good question. We absolutely looked at other configuration management systems like Ansible and Chef and Puppet. Juniper actually had a framework that was available, the PyEasy, as you mentioned before. Those libraries were already there. For us, we used PHP primarily because we had interfaces with other systems already, like I mentioned earlier, our IPAM, our Wi-Fi solution, and we knew that we could bridge them all together. All of those other systems would have worked just fine, and I think for other customers, it's a good fit. It just kind of depends on what they have in their environment deployed today. The beauty of it really is it doesn't matter as long as you've got a DevOps team that can write to the netconf standard. You can solve the complex problem. So the zero-touch deployment process is well documented on the Juniper website, and actually there's a reference architecture and kind of a guide that we used as a way to kind of get started. It's a bit of an eye chart here, but the process is pretty straightforward. When a device boots up, it makes a DHCP request on the network. The DHCP servers reply with an IP address. It gets its information, reaches out to either the cloud or wherever you're hosting the configuration, downloads the image from the location, kind of reboots itself, compares the software versions, and then ultimately the device boots up with the new config. Again, there's some really good documentation on Juniper's website that outlines this process in the kind of a ladder diagram format that helps really illustrate exactly how this process works. The really nice thing is that it doesn't require a whole lot of infrastructure to support it. So to dive a little bit into the weeds and kind of talk about what we actually were able to achieve by deploying the automation within our network. I mentioned earlier being able to reduce the operational costs by not having to add people. That was absolutely key to the success. The automated provisioning portion of it really allowed us to keep a level of consistency, a gold standard, and consistent configurations across all the different deployments. Freeing up those technical resources to be able to focus on complex orders, responding to larger opportunities that required more attention than a typical deployment would. Time to market, we are now able to deploy an SRX and 10, 20, 30, 40 EX switches. We've scaled as high as 50 EX switches behind SRX 240, and we can have them all properly configured with a base config in under 20 minutes. And what that really does for us is it allows our installation and repair or account managers to spend more time with the customer and kind of managing that relationship than it does heads down and fingers on keyboards entering CLI commands. In terms of the scalability, we've not really reached a max yet in what we're trying to accomplish. I'm sure that there are, but we believe that we should be able to take this deployment, put it in a brown box, and ship it across the country. And as long as they've got an internet connection, then that device should be able to boot up, phone home, get its configuration, and come online within 20 minutes. We've developed a product in a way that we believe it'll work on our network or other people's networks equally as well. In terms of revenue, it's one of those things that was kind of unexpected, but it's been a really nice addition to the portfolio. we started with 0 customers, and at the time of this recording, I think we're approaching 100 within 12 months. And from our perspective, where we didn't really have a lot of MSP business or managed infrastructure, this was kind of an added plus for us.
Great. Given this rapid customer growth, did you have to expand your organization to handle this additional support?
So, we probably ultimately at some point in the future will. We're still trying to figure out what the FTE to customer ratio is. As it stands today, we've got 4 people who are responsible for the support of those 100. So it's about a 25-to-1 ratio. The operational and support burden on the staff today does not dictate the need to add additional headcount. But I do expect in the future we will have to augment staff. But we're gonna let them kind of tell us when that point gets. And I don't know if it's a 50-to-1 or 100-to-1 today. Right now, once the customer's been onboarded, they don't have to call us very often because it just works.
Great. And,
Great.
Are there enhancements to the solution you are looking to add moving forward? And if so, are there any additional automation tools you're considering?
We continue to expand what our tool sets look like. We have a kind of a feedback loop with our installation team to understand what their pain points are. Are there things that we could build into the golden config that lessens the need for manual intervention? I'll use an example. We also have a hosted voice product that rides this common infrastructure, and we realized that we needed to implement kind of a quality of service aspect for the voice product. So when it's deployed in conjunction with our other products, that it needed to be ready to support it. So it's kind of an iterative process. As we feel the demand is there to include it into the automation, we will certainly add it in there.
Thank you, David, for sharing your automation experience with us today. It's always interesting and exciting to hear from our customers how they have effectively used automation to optimize operation while creating new opportunities. Thank you, David and Martin, for your insight on Juniper automation capabilities and EATEL's device automation experience. Automating network device configuration drastically improves efficiency. As David mentioned earlier, EATEL managed to reduce device provisioning from hours to under 20 minutes. Despite rapid customer growth, EATEL managed to maintain the same level of support without adding additional resources. This will ultimately translate to reduction in overall operational expenditures. Open programmability, where easy integration with third-party open source interface and toolkit can facilitate and expedite device automation. Once device automation is in place, size of deployment is no longer relevant, thereby drastically increasing scalability. Automation also replaces extensive manual processes which tend to be time-consuming and error-prone. More importantly, automation provides substantial control, ensuring consistent and unified device configuration. Last, automation enabled EATEL to rapidly address new market opportunities, as evidenced by the rapid growth from 2 to over 70 enterprise customers. I hope you found this webinar informative and educational. To learn more details about other Juniper use cases, please visit our automation page on juniper.net. Thank you. I'll see you next time.